Hello everyone, I'm Jake. The topic of AI-generated seamless textures has been around since AI came out. Today I will share with you my operational experience in some projects. All seamless textures in the directory are generated using ComfyUI and without going through other software. In addition to the base color or diffuse color, there are also normal, height, and curvature maps. The curvature map is often called an edge map. Today I will mainly introduce ComfyUI and cover A1111 and the material attribute conversion tool Materialize. Let's first look at how to create seamless textures in A1111. The most critical point is the prompt. I have listed a general rule for positive prompt divided into several parts. First, the green part is a directional description of the texture. Let's say it's organic, attractive, photorealistic, or three-dimensional. The cyan part requires that the generated graph be seamless or symmetrical. If the tiling option is enabled, this part can be omitted. I will introduce the tiling option in a moment. The yellow part is essential. Use pattern or texture to specify that the generated image is planar rather than three-dimensional. The purple part is the texture theme description, such as brick, grass, stone, etc. Some modifiers can be added in front. The next gray part is the optional elements description and the arrangement description of the elements. For example, the ones listed here include shapes, natural variations, artificial straightforward arrangements, etc. Because what we want to generate is a texture, in addition to the commonly used negative prompts, we can also add words such as shadow, highlight, reflection, and shiny to reduce the interference of these elements. In this case, the prompt is organic texture of flat weathered dark cliff rock. The checkpoint uses Juggernaut XL, the sampling method uses DPMPP2 mcaras, and the resolution is 1024 x 1024. Please note that there is a tiling option in the Quick Settings bar. In the latest A1111 version, this is a hidden option. How to make it appear? In the Settings menu, find the Quick Settings list in the User Interface and enter Tiling. Click Info to see more setting parameters. There is an extension when creating seamless textures called asymmetric tiling. Let's turn off the default tiling option first. Its advantage is that it can control the X and Y directions separately. This page has a detailed introduction to it. After a period of waiting, the texture has been generated. I generated two textures, one using default tiling and the other using asymmetric tiling extension. The results make no difference. The following focuses on the workflow in ComfyUI. Let me first introduce a few tiling-related custom nodes. For me, the first choice is the Seamless Tiling node, the most complete and reasonable custom node. There is also a model node in MTB nodes that can create seamless textures, but some important functions are missing. The following two custom nodes can also create seamless textures, but they need to replace the default KSampler node, which is not reasonable. I'll open the workflow file. There are several methods included in the tiling process. Let's take a look at them in turn. The first is the default process without tiling enabled. The second enables the Model Patch Seamless node in the MTB custom node. The third one is Seamless Tiling. It provides multiple nodes such as the Seamless Tile Model node, which can control the XY direction independently. There is a circular VAE decode node, including a single node with integrated functionality, and a separate make circular VAE node that does not affect the default VAE decode node. Using this set of nodes can add seamless functions to the original workflow and can be switched on and off at any time, so it is my first choice. As for the tiled KSampler custom node, which integrates the tiling function into the default KSampler node, if the corresponding function of ComfyUI is upgraded, it may not work properly. In addition, using it will cause the image generated by the default KSampler node to become seamless. We'll see again later. The last asymmetric tiling is also integrated with KSampler, so it is not used. The Juggernaut XL model and default SDXL VAE were selected in the workflow. The IPAdapter process has also been added to this workflow to obtain results similar to the reference images. There is also the ComfyUI upscale node. It can directly output images with a resolution of 1024 or above after being enabled for the SD15, SD20, or SD21 models. There are also SDXL Lightning processes and image-to-image processes. Let's take a look at the default process first. Other settings are the same as in A1111. This image is not seamless. I used a repeat image batch to generate 4 identical images in a 2x2 layout. This is a quick way to check if the image is seamless. Let's try MTB tiling. Use the random seed number from the last generation. Seamless images can be created by simply embedding the model patch seamless node in the MTB node into the model flow, but the XY direction cannot be controlled independently. Note that there are 3 VAE code nodes here. The first one is the default. The second one is also the default but has tiled functionality. The third circular VAE code belongs to Seamless Tiling custom node and is an important node missing from the MTB custom node. I use the Image Enhance Difference node for comparison. The first is to compare the results of the 2 default VAE codes. You can find slight differences between the 2 images in the comparison image. When the generated resolution is not high, such as within 1024, VAE code will be more efficient than VAE tiled decode and the result will be better because no cropping and tiling is performed. So what does circular VAE code do? As you can see from this picture, there are obvious differences at the edges of the picture. These differences are the key to whether the pictures can be perfectly and seamlessly tiled. When zoomed in, the picture appears seamless at first glance, but irregular jagged flaws appear at the picture edges. Using circular VAE code generates perfect seamless textures. Let's look at seamless tiling. The usage method is the same as MTB node and it has the function of independent control of XY direction. There are also 3 VAE code nodes here, one of which is the default node. This group is the default VAE code node and the Make Circular VAE node. There is also a circular VAE code node that integrates the above 2 nodes. We already know that the edges of the images generated using the default VAE code node are defective. The other 2 methods can deal with this flaw and the results are the same. I prefer to use the Make Circular VAE node to control it individually. The 2 processes below are seamless only in the X direction and seamless only in the Y direction. For tiled KSampler tiling and asymmetric tiling custom nodes, although the same results can be achieved, I do not recommend them because they replace the default KSampler. Tiled KSampler tiling custom node contains its own circular VAE code node. Let's look at its biggest issue. We still remember that when using the default KSampler, the generated images are not seamless. But after using the tiled KSampler node to generate images, let's try to use the default process. Change the number of steps and generate 2 images. You can see that the images generated using the default KSampler will also become seamless. It seems that a global tiling option is enabled. We can only change the tiling value in tiled KSampler to 0 and then use it to generate a picture to turn off the global tiling option. I enabled the Save workflow to save seamless maps. At the same time, the deep bump node provided by the MTB custom node is used to convert the color map into a normal map, a height map, and an edge map. In other words, we can use ComfyUI to generate seamless maps of the main material properties with one click. Please note that the normal map generated with Deep Bump is applied to Unity format. When used in UI, the green channel needs to be flipped, which will be introduced later. Next, we try the image-to-image process. We first use two methods to obtain the generated metadata of the image as a reference. The WD14 tagger node can infer the prompt based on the image. You can use a custom node like the one I created to read the metadata directly for an image with metadata. This metadata can be used as a reference for creating seamless textures. Unfortunately, WD14 tagger's inference of prompts for texture images is not ideal and has no reference value. You can go to lexica.art to have a look. Users have shared a lot of textures created using AI. You can refer to the prompts of the textures. We reduce the denoise value and generate an image. Next, we try the IP adapter, but be careful to close the image-to-image workflow first. I used the same reference image suitable for SDXL's VLTH settings, reduced the weight and endpoint value, and generated the result. Compared with the image-to-image process, IP adapter generates images with a wider range of changes and may achieve unexpected results. I explain further with this comparison chart. I used an organic reference image which has nothing to do with rocks and listed the results generated by different weights and endpoint values with the same random seed number. It can be seen that when setting the weight around 0.4 and the endpoint value around 0.2, the generated results are better. Next, we try two texture checkpoints. One is texture hell, which is based on the SD 2.1 base model. Texture needs to be added to the prompt to trigger it. The other is texture diffusion, which is based on the SD 2.0 base model. PBR needs to be added to the prompt to trigger it. I changed the texture diffusion checkpoint, enabled the default and MTB tiling processes. Enable the ComfyUI upscale workflow to directly generate 1024 resolution images. The first generated image looks like nothing. I add PBR to the positive prompt and regenerate. The result, although very texture-like, is not ideal. Let's try texture hell. The result is okay, it looks like a rocky texture. I think the texture hell checkpoint could be an option. Then I tried SDXL Lightning for quick generation. Select the Juggernaut XL model and enable SDXL Lightning LoRa. The parameters of KSampler need to be adjusted accordingly. Overall, SDXL Lightning's understanding of textures is still relatively lacking. If you are interested, you can try SDXL Turbo and SDXL LCM. However, I would not use these quick generation methods to generate seamless textures. I then observed and generated other material property maps in Materialize. Click Show Full Material to observe the material. Create a smoothness map or inverse roughness map. Create an ambient occlusion map. Then create material property maps in Materialize and replace the maps generated in ComfyUI. Save the textures generated in Materialize to the directory and compare them with the textures generated by ComfyUI. There are differences in the directions of the two normal maps, which I will explain later. The height, normal, and edge maps generated in ComfyUI are more detailed than those generated in Materialize. Please note that the style of the normal map is different in Unity and UE or Maya and Max. It can be seen from the comparison images on the right that the red channels of the two are the same and the green channels are inverted to each other. Before creating a normal map, you need to create a depth map. By default, cyan faces the upper left and purple faces the lower left, which is the normal map style of Unity or Maya. If you want to use it in UE or Max, click Flip Normal Y to get the normal map in the correct style. Or you can change the default normal map style to Max style in the settings, and Materialize will automatically flip it. I use Renamer to organize the names of the textures. First delete all characters, then insert the subject name, then add the serial number, and finally insert the texture type as a suffix. The Tile Maps function in Materialize can make maps seamless. Click Show Full Material and you can see from the 2x2 tiling result that this texture is not seamless. The Tile Maps function is based on height blending, so we create a height map first. Adjust the parameters and see the results. Generate other material attribute maps and process them together with tile maps. Let's take a look at how the textures look in UE. The material has been set up and the roughness uses the inverse smoothness value. The normal map used is generated in ComfyUI. Note that the flip green channel has been turned on to ensure it can be used in UE. Compared with the normal map generated in Materialize, the style is consistent and the details are more. The height map is used for the world space position offset of the model for easy observation. The model uses 2x2 tiles. It's great. Thank you all for watching. See you next time.